And I'm going to share my screen again. So our main objective in this lecture is, again, as we said, is to go through the control structure. And one of the control structures is called selection structures. That's how programming make decisions. So again, we will go through what is a selection structure. We should also discuss about the relational comparison operators. Now, in order to have a program to make a decision, we have to write a condition. And the condition have to be yes or no. So programming language is more or less a logical decisions, and that something is true or something is false. So we have to use the relational operators. A relational operators is like greater than, less than, or equal. So for example, I may have a condition that if the hours work is greater than 40, then we need to calculate an overtime for the employee. So if it's yes, we calculate overtime. If it's no, we don't. And also we go through what we call the logical operators. So we have three types of logical operators: the AND logic, OR logic, and also NOT logic. Now we normally use the logical operators, especially the AND and OR, to combine two or more conditions. And we shall go through that. Also how we can make a selection within ranges and the precedence when combining AND and OR. So normally, if you have all these three logical operators combined in one conditions or in one expressions, there's order. It's more or less like arithmetic precedence. In arithmetic, we know the parentheses start first, then exponent, then we have multiplication, then addition, subtraction, multiplication, division, addition, subtraction. In logical operators, we start with the not first. So not will execute first, then the n, and then the or. N is like a multiplication, or it's like addition, then not. Now, if I have a condition in the parenthesis first, even the condition is n or, that will execute first. So always parentheses also execute first when we combine many logical operators and we have a parenthesis with any of the operators that will execute first. So we start with the selection structures. Here we say that they are Boolean expressions that can be only true or false. So Boolean expressions, and that's why we say it's a logical decisions. There's only two outcomes, whether a condition is true or false. So every computer decisions will yield a true or false. And sometimes true can be yes and false can be no. And sometimes true can be one and false can be zero. For example, if you are using Java, Java have a Boolean data type which is true or false. So you can use true and false if you declare variable as a Boolean data type. But in C++, we use a 1 and 0. 1 means it's true, 0 means it's false. So this is always used in every selection structure. Always the outcome should be 2. Either an expression is true or false, or a condition is true or false. So we have a dual, this is called a dual alternative or binary selection structure, which means we have two-way selections. Now with the flow diagram or the flow chart here, we went through this already, the flow chart. We only learned two different symbols. We know process is a rectangle, so this is a process. This is where calculations or whatever task we want, this is where it will take place at. Then we have the parallelogram, which is for input and output statement. Now we also have a diamond here now. This diamond this diamond I would say is a condition. So when I write I have a flowchart diagram and I see a diamond, that means I have a condition. So if we have a condition here, if the condition is yes, then we are going to execute the task on our right side. we are going to execute the task on our right side. If the condition is false, we go to the left side, which is no, because the condition is false, so it's no. So we execute the task on our left side. So this is more or less called a two-way selection structure. Here we use the term dual alternative for binary selection structure, which means it provides an actions for both true when the condition is false for the condition. So if the condition is true, which is yes, we execute on the right side task. If it's false, we execute the left side task. We also have what we call the single alternative or unary selection structure. This will provide only an action for only one side, most of the time for the true section. Also, we call it one-way selection structure. So again, I have a condition. The condition is the diamond symbol. If the condition is true, which is yes, I may execute what is on my right side. If the condition is false, there's nothing, I will just keep going. And execution again, the down arrow tells us that execution is in sequential order from top down. So execution starts from the top all the way down. So here we have some example here using the only thing we are going to be concerned about is the diamond symbols. That's where we have our condition. So let's go through the first flow chart here. We have some declarations. We declare a variable name. The data type is string, which means it can be characters, one or more characters, or a word. Then we have some variables here. The first one is hours. The data type is num, which means it's a number. The second one also is a number. The variable name is rate, and we initialize it to $15 or 15.00. So which means the rate is $15. Then we have another number, the work week. The work week is 40, which means by default, employees work up to 40 hours. Then we also have overtime, variable name overtime. We initialize it to 1.5, which means if the hours is more than 40, if you are paid $15 an hour, then it will be $22.50, which is one half. Half of 15 is $7.50. $7.50 plus the original 15. That will give us $22.50. And also we have a variable name pay. This is where we are going to store the employee's pay. Then we have a variable name quit. We initialize it to 222. If we enter that value, then we are going to quit the program. So those are all the variable we need, all the variable declaration. Now we have a function here which is called, the function is housekeeping. The housekeeping function is here, which tells us that if I execute this function, it will give me an output saying that this program computes the payroll based on overtime rate of whatever the overtime is, 1.5. After 40 hours, enter employee's name or quit to quit. So this is the housekeeping function here. It just print these instructions here for us. So now we saw the last instruction said we should enter what? Enter the employee name or quit. So here I'm going to enter the employee name. Now when we enter employee name, we are going to say, okay, is employee not equal to quit? Now, if employee is equal to quit, then we have to stop the program. We cannot go and execute everything here. So remember, this is a two-way. If the condition here is true, we go to the right. If the condition here is false, we go down. So name not quit. Again, less than and greater than symbol together means not. Again, we will go through the relational operators soon. So this condition said name not equal to quit. Yeah, I enter Charles. So that condition is true. So if it's true, we are going to have a detail loop. Then we're going to do something over. So now the thing we should know is that when you have a condition, and when the condition is yes, it's like you are going back again, which is like a looping. Then this means this condition here is a representation of a loop. It's inside a loop, which we will discuss in chapter 5. But this is just an example to show us. So we keep doing something over and over until we enter quit, then we come out of the program. Then we call the function finish to do something. Now this is a selection statement now, the example here. Here we have a detail loop. Then there's instruction that we should enter the hours work. We input the hours. And now we check if the hours is greater than 40 because work week is a constant variable and they initialize it to 40. So when I say a work week, it means the content inside is 40. So here we are checking if the number of hours the worker work is over 40. If it's yes, then we need to calculate overtime. So the pay will be work week times rate, which is my first constant 40 hours is a regular rate. I have 40 hours. If I'm paying $15 an hour, then 40 times 15. If I work for 55 hours, then I'll say plus 55 minus 40 will be 15. 15 times 1.5. Now, instead of $15, they are paying me $22.50. Go 1.5 times $15 will give me $22.50. And that's the mathematics here. Again, this is very small if you cannot see it. The condition say if hours greater than work week, which is if hours is greater than 40, then we need to calculate the regular hours for the first 40 hours times the regular rate. Then the remaining hours, we multiply that by 22.50, which is 1.5 times 15. From the declaration here, they say overtime is 1.5. So we calculate it. Now, if the condition is false, which means the worker work either 40 hours or less, then we don't calculate no overtime. So it will be pay equal to hours times the rate. That's it. So this is the new thing we are learning. Now this is again two-way selection statement or control structure. You have a condition hours work is greater than work week. If it's yes, calculate the regular pay plus overtime. If it's no, then the worker didn't work an overtime. He didn't work any overtime. So we just multiply the hours times the rate. That's it. Then from there, we are going to print. Here we say output, the pay for the name of the employee that we enter earlier time is whatever amount we calculate, either the left or the right. The right including overtime, the left excluding the overtime. And also what we have here is the same thing, the pseudo code here. So we can go through the pseudo code for a second, especially the detail loop section. So here they say enter the hours work. We input the hours. Then we check if the hours is greater than 40 or work week. If it is, then we have to calculate the overtime with the regular pay. So the regular pay will be work week times rate. Now, plus the hours you work, if it's more than 40, let's say if it's 50 hours, then I'll say 50 minus 40. So that means I work only 10 hours overtime. Then I'll multiply that by the rate times the overtime rate, which is 1.5. So it's like your mod 15 will be 22.50. Now, if the condition is false, then we go to the else section, which means the hours I work is less than or equal to 40, no overtime. So if there's no overtime, which is the else, we just multiply the hours by the rate. But this will be either 40 or lesser. Then the rest, we just print the output. then we end for finish. Now, if we go through the lectures, hopefully we will understand this. This is just an example that we can use the condition for loop. Looping means we're going back again to do something over until the condition is false. Selection statement, we don't go back because we are not repeating something. We just want to select one of the statements here. If it's true, we go to the right. If it's false, we go to the left. Now let's go through the lecture step by step now. So here again, selection structure. This is again not a programming language, but we are using English to explain how programming structures work. So we have if, then, else decision. This is two-way decision. In Java, we call this if-else statement. If else, there's no then. So if, then, else decision. So the if, then section will hold the tags if the condition is true. So let's go back to the diagram again here. The if else section, if then section will be here. Yes. Then if the condition is false, it will be else. So else will be when the condition is no. Yes means when the condition is true. So here we say if then cross, this will execute. Any statement after if then will execute again if the condition is true. In the else section, when the condition is false, everything there will execute. And again, programming, there's no reasoning. Either you are one or you are two, whether it's true or it's false. There's no reason. It's okay. I didn't make it to school today because I was late. So I'm not going to mark you late. I was late. The train was the problem, or some other issues which is beyond your control. So since the condition of being late is beyond your control, I'm going to mark you present. But programming doesn't think that way. It doesn't reason why. If you are late, they say, okay, the time to be not to be late is 8:45 or less or earlier. Well, if it's after 8:45, even with 1 minute, you are late. With 10 minutes, you are late. Late is late. And there's nowhere to give a reason that, okay, because the train is beyond my control or my car breakdown, I couldn't, So that's one thing we should know about computers. It's logical, binary decisions, true or false. Now, here we're going to learn about how to use the relational operators. We saw the relational operators, sometimes called relational comparison operators. We saw it in our example of the calculating the overtime. We say if the hours work is greater, greater is a relational operator. So we have 6 of them, 6 types. The first can be greater, second will be less than, then third will be greater than or equal, fourth will be less than or equal, fifth will be equal, sixth will be not equal. So always we have 6 relational operators. Every programming language has 6 relational operators. So they gave us example here. Here we want to do equal. So we said, oh, sorry. So here we say is 20 equal to 20? Yes, it's true. 20 is equal to 20. That's true. So the answer, again, as we said, programming will give you only 2 outputs. Either something is true or something is false. Now, is 30 equal to 40? No, that's false. 30 and 40 are not the same. Or if my condition should be is 30 not equal to 40, then I'll say it's true because 30 is not equal to 40. It's true. But 30 equal to 40 is false. So these are the relational operators. We have equal. This is to check if 2 or any value is equal to some variable, some content of a variable or another value. We also have the greater than, which we can check. For example, the hours is greater than 40. If so, then let's calculate over time. We also have less than. Is hours less than 40? If it's true, then don't calculate overtime. Overtime only happens after 40 hours. Then we have a greater than or equal. So if I say hours is greater than or equal to 40, it means including 40. First, we say hours is greater than 40, which is excluding 40. If I have 40 and you have to ask me a condition, if the hours that I have is 40, now if it's greater than 40, it's false. It's not greater than 40. But if I say the hours is greater than or equal to 40, since I have 40, the answer is true because it's equal to 40 also. Then we have the one we say not equal. So not equal is opposite of equal. I can say age is not equal to 50, which means the age is not 50. Now, all these three symbols, when you are writing them, don't have a space between, there's no space between them. So I'll write a greater sign, then equal together as one word. There's no space between all of them. Not, we have both less than or equal, less than or greater symbol together. No space between. So here we say that any decision, we said that any decision can be made with only three types of comparison operators, either equal, not equal, greater than or less than, or not equal. And we say this best restricts usage to if without an else. If we don't have no else, that means we only take action when some comparison is false. So this is a good example here. So again, this is not a programming language, just the structure of it we are discussing. So this is more or less like English. Here we say if customer age is greater than or equal to 65, if this condition is true, then we give a discount of 10%, which is 0.10. Else we don't give no discount, so we assign discount to 0. If you are less than 64, you are less than 65, you are not a senior citizen. So the condition says that my age or the customer age should be greater than or equal to 65. So 65 or more. Then you get a discount of 10% or 0.10. Else, if the condition is false, that is the else section. If your age is less than 65, then the discount is 0, no discount. Now, the same thing applies here. Also, we said that if customer age is less than 65, then the discount is 0. Else, we give him 10% discount. Now, it's based on the condition that we change the false to true and true to false. Because here we say greater than or equal to 65. But here we are saying it's less than 65. So if it's less than 65, the discount equal to 0, the else section will execute for the first example. But here, since the condition is already checking if it's less than 65, then if it's true, then the discount is 0. So the else section will be when the discount is 10% or 0.10. And 0.10 discount means the person is more than, again, 65 years or equal to 65. So we have another example here. Here we have a customer code. And the condition said, if a customer code is greater than 1, if that condition is true, then we give a discount of 25%. If it's yes, means the condition is true. So we go and give the discount 25%. Now, if the customer code is not sorry, this is 1, I thought it's 12. That's a question mark right here. So if the customer code is 1, if it's yes, we give him 25% discount. If it's no, then we give him 50% discount, 0.50. So we can write a pseudocode here by saying the condition first. If customer code is not equal to 1, then the true section will come. Discount is 0.25. Else, the false side will come. Discount is 0.50. So that's what we have here. If customer code not equal to 1, then we assign 25% to discount. Else, we assign 50% to discount. So here they say we should avoid some common errors when we are writing relational, using relational operators. One of the error will be the boundary. So when you are using greater than or less than, you should be careful. So for example, if I say the age is greater than 40, it means 40 is not included. If you include the 40, then you have to say greater than or equal to 40. The same thing applies to small. So if I say age is less than 10, it means only from 10 down. Less than 10 means only from less than 10. And if it's a whole number, less than 10 will be 9, from 9 down, excluding the 10. But if I want to include the 10, then I'll say less than or equal to 10. That means I'm including the 10 also. So that's what we are saying here, missing the boundary or the limit required for selection. Now, next we go to the logical operators. So we said we have the and, or, and not. So first we go through the and logic operators. First, we know a compound condition. Anything that is compound, for example, in mathematics, if we use the term compound, we mean there is 2 or more of something, whether it's a variable or function. So when we say compound condition, it means when we have more than one condition. Or we can say compound statement. It means I have more than one statement. Okay, so if no question, we keep going. So first we start with the end decision. One thing we should know about end decision is that it's a binary operator, which means you have to take 2 conditions. And for the execution to take place for the true section, the 2 conditions have to be true. So for example, I may have a condition saying that if a student city is New York, and that's my logical operator, and student score 80% or student grade is greater than 80, then do something. This means I use the and, so this means that student must meet both conditions. Where it's from, his score. Let's say we say a student city or student from Bronx and his score is 30%. It means if student's score is 30% and it's from Bronx, we are going to execute the true section. Else, which means the student didn't meet any of the criteria or meet only one criteria, then we do differently. So when you are using and, all your conditions must be true in order to execute the true section. If, for example, if I have 3 conditions and 2 of them are false and 1 is true, we still have a false. If only 1 is false and 2 is true, we still have a false. Because with the and operator, everything has to be true. So this is an example here. We have the same program, so there's a declaration here. We have the loop to execute some conditions. Then here we have statement here, but you can see here we have two conditions. So this is called a nested if statement or selection statement. First, I said that if the call made is greater than calls, if it's no, then we skip. We don't go inside the second if statement. But if it's yes, then we are going to check the second statement. We say the call minutes is greater than minutes. Now you can see that here we have two conditions which we have to check. If first is true, you check the second one. If it's true, then we do something. If it's false, we don't do anything. Now, instead of writing the two conditions like this, I can use the AND operator since both conditions have to be true. So I can use the AND operator saying that writing only one condition. So I'm going to have only one diamond symbol. The diamond symbol here will be only one. Then I'll say that if call made is greater than calls and call minutes is greater than minutes, then do something. And this program will run more faster than this because it's like we combine two conditions together like one expression. So that's what we are learning here. Here, these two conditions have to be true in order to execute this. Now, nesting and end decisions for efficiency. So as I said earlier, this program will not be too good, especially if you have so many, because you check first condition, you have to check the second one. If it's true, you have to keep checking. We can have third one, fourth one inside, you keep checking. But if I use N, I've checked only one condition because all the condition is written once with N between. N will combine the two or more conditions together. So when we talk about efficiency, yes, when you use the N for the condition, it's better than using separate conditions. So here we say when nesting decisions, either the selection can come first, which means this selection, I can bring the selection that call minutes greater than minutes first before the calls made greater than calls. Either condition can come first. Now, the problem is the performance. So here they say performance time can be improved by asking questions in the proper way. What we mean is that if I have n conditions, if only one condition is, let's say I have 100 conditions, 99 conditions are true, but only one condition is false. But because we have only one false out of 100 conditions, we're still going to get our last output as false. So that's why we say the n is like a product. For example, 1 times 1 is 1, but 0 times 1 is 0. 1 times 1 times 1 times 0 is 0. That's the binary algebra. But when you are doing OR, it's like addition because 0 plus 0 is 0, but 0 plus 1 is 1. 1 plus 0 is still 1. 1 plus 1 is still 1 for binary algebra. So when you are writing the end decisions, ask the question that is always or it has a chance to be false. Questions that have chance to be false should be first, because when the condition is false, we come out of the statement section. So this is the same example we did before. There's no n here, so we have first condition. Then this is called the nested if statement. We have one if statement inside the other. So here the efficiency is not good. It's only good if you can write the condition that have higher chance of being false first. Because if the first condition is false, what will happen? I can't go and check the second no more. I'll come out of that section. So this is how end look like. And the second also the same concept. So we can see the pseudo code here. Here we said that if calls made greater than calls, then if calls minutes greater than, so these two conditions have to be true in order to add the calls bill plus the premium. If one of them is false, we skip it. So the conditional end operator is very good. It improves the performance of our code because I may ask two questions at the same time instead of, let's go back, instead of asking one question first, if it's true or false, then I'll ask a second question. No, you can ask all the question that, for example, here we said, the calls made is greater than calls and calls minute is greater than minutes, and everything will be on one condition. Then we do execute it. So this again save time. So conditional end operator, simply called end operator, we say we'll ask two or more questions. It will ask two or more questions in a single comparison. So as our example, nested if statement, it asks two questions, two different ways. But with the end operator, all the questions are like one question together. We combine it using the end operator. We also have what we call the truth tables for end operator or the logical operators. Normally, the truth table will describe the truth of an entire expression based on the truth of its parts. So what we mean by this is if I have only two inputs or two conditions, then I'll say that if first condition is true and second is true, then our output will be true. If first condition is true, second condition is false, the output will be false. If first condition is false, second condition is true, the output will be false. If first condition is true, second condition is true, the output will be true. So the combination will be 4. It's like binary operator. You raise the base to the number of units. So for example, I have two connections. The base for binary operator is 2. So 2 to the power 2 give me 4. Now if I have 3 inputs, I will raise the 2 to the power 3, which will give me 8. So the possible combination of the answer will be 8. So if no condition, no question, let's keep going. So this is an example now. We can see the first one, we are using the end operator. So here we say if calls made is greater than calls and calls minute is greater than minute. This will run very fast because we have only one condition. If the condition is true, do something. If it's false, don't do anything. It's better than writing the nesting if. You write one condition, if it's true, then you write the second condition. So this means if I'm executing this program, I check the first condition, is it true? Yes. Then I'm coming to check second condition, is it true? Yes. Then I will do my task. But here, I'll check all the two conditions together as one unit, they combine them. I'll check it. If it's true, then I'll do my whatever I have to do. So it will be more faster. Now here they say we should avoid the common errors in an end selection. So they say the second decision must be made entirely within the first decision. And in most programming language, the logical end is a binary operator. A binary operator means you have two inputs. So we always have the left and the right section. Okay, so if no question, let's keep going. So avoiding common errors in end selections. Here we have a condition saying if calls made is greater than calls. If it's yes, we do this. Now we have a second condition. We check if calls made greater than this, we do this. This is wrong. This is or. Remember, we say the or. If I have two conditions, if one of them executes, we still do something we want to do as true. So with or means only one condition have to be true, or both of them have to be true. We execute the true section. But when you look at this, the way they write it, it means If my first condition is false, I'll come and check the second condition. If it's true, I'll still execute. So that's like doing or. So that's why here they say don't do it. This shows or. And we'll see the example of or. So if I want to make this as true, I have to bring this condition to only the yes section, which means if this condition is false, no any condition will be checked. Unless it's true, then we check the second condition. So next we go to the or logic. So the or decisions again is like a and decisions. They are binary operators. They will take to at least a minimum of two conditions and combine them as one. But the good news here is that in N, we say that all the conditions have to be true in order to execute. But with or, only one condition has to be true. So for example, if I have 100 conditions and 99 of them is false and one is true, I will get true output. As far as we have one true out of the 100, our output will be true. So this will take action when one or other of the two conditions is true. A good example here, are you free for dinner Friday or Saturday? So which means if I'm free on Saturday, I can still go. If I'm free on Friday, I'll still go. Only one condition has to be true. So we have the flowchart diagram here. So our condition here says course made is greater than course. If it's yes, we do something. If it's no, then we check a second condition. If it's no, we go out. If it's yes, we do something. This is correct because we have all here. The condition is no, but here we still have a condition. If it's no or yes. So writing all selection for efficiency, this is the same as the AND operator also. When we combine two or more operators using two or more conditions using logical operators, and the efficiency is good than having the conditions separately. So this is writing or. We check first condition. If it's true, do something. But if it's false, we check the second condition. If it's true, do something. They are doing the same thing. If it's false, so you can see that with the or, the only time we don't do nothing and it's false is when both conditions are false. So if it's false, no, another false, no, then we don't do anything. But if it's false, no, and it became true, yes, we do something. Or if it's true, yes, we don't care about the other one, whether it's false or we still do something. So with the or, the only time we don't do nothing is when both conditions are false. So if it's no and the second condition is no, which means both conditions are false, then we continue, we don't do anything. So they're using the or operator, we say it's only one boolean expression in an or selection must be true to produce a result of true. So if I have 100 conditions and one is true, I'll still get true output. So the same thing, we should avoid the common errors in N. The same thing applies to all selection also. So for example, here they say we should add 20 to the bill of anyone who makes more than 100 calls. Now they say more than 100. That means 100 is not included. 100 is not included. And to anyone who has used more than 500 minutes, which means if you use 500, you are not included. So make sure that the Boolean expressions are complete. We should also make sure that the selections are structured And also we should make sure that to use all selection when they are required. And the last, we should make sure that the expression are not trivial. So again, we have another example. The first flowchart, we can see we are using a logical decision, which is or. We have two conditions, but because we are using or, we can join the two conditions together. This is faster than doing the one down here. The one down here, we check the two conditions separately. So here we say that if the cost made is greater than cost or test sent is greater than test, then customer bill will be customer bill plus premium. If the condition is false, the condition will be false if only both conditions in the combined with the or is false, then we come out. Or we can make it in this form to take the and the or logical operator away by saying that if cost made is greater than cost, if it's yes, do something. If it's no, then check if it's the test sent is greater than test. If it's yes, do something. If it's no, don't do anything. So these two codes are the same. The first one is using logical operators. So it combines the two decisions. The second is not using logical operators, so it's separated. So the same idea here. We say if the patron age is less than minimum age and the patronage is greater than man's age, then the price is discounted price, else it's full price. So here we are trying to say that if the age is less than minimum age and also greater than maximum age, then we give it some discount price. If both conditions or even one of them is true, then we have to execute the else section. So the last one will be the not operator. With the not operator, we call it a Unary operator because it takes only, again, one condition and it will negate the condition. So for example, if I say not false, it means it's true. Not true means it's false. And we can use also values like not 20 means the value can be any value, but it's not 20. So we have a statement saying age is less than 80. If age is less than 80 and it's true, then not true will give me false. So the condition here, if the age is greater than, let's say if the age is greater than 18 or equal to 18, then my output will be true because the condition will be false. We have age less than 18, but if I say my age is equal to 18, then the output will be false. So if it's false, if I negate it with not false, that will turn to true. So here we say if not true, then it's false. If not false, then it's true. And it's again unary operator because it takes only one condition. So that's what we have here, one condition. Or I can have if age is less than 18 and let's say score is greater than 80. If all the two conditions combined with n is true, then not n will be again false. Here also we can avoid the common errors, essentially the boundaries. So here they say be careful not to create trivial expressions or incorrect code. Example here, if not employee department equal to 1, which means if employee department is not 1, or not employee department equal to 2, that means if the employee department is not 2, then the output is employee is not in department 1 or 2. But we should be careful in this because why? We have a parenthesis separating them. So it's like you are doing both separately. We know the not will happen before or. But if we do it in this form, then the or will happen first before not. And what I mean happen is execution. So if I have not employee this or not this, then not will execute first, and then not here also will execute before or will execute. So the two not will execute before or. But we want it in this way. We want to check the two conditions. If they are true, then we negate it. If they are false, then we negate it. So this will be the best. Employee department is equal to 1. Is it true or false? If it's true, then don't even check the second one, because if the second one is true or false, we still get true. So which means all the condition here is true. Not true will give me false, or not false will give me again true. So the first is wrong because first we are going to check if employee department is 1. If it's true, then we make it not true, false. This also, if it's false, we make it not true. Then if one of them is true, all will be last. Again, here we want not to execute last because parenthesis first before not. Also, we can make selections within ranges. For example, between 20 to 50, greater than or equal to 70, which means anything from 70 going, etc. So here we say we can compare variable to a series of values within some limit or between a limit. Now use the lowest or the highest value in each range. Then you can adjust the question logic when using highest versus lowest values. So for example, here we say it's good to use greater than or equal or less than or equal. Don't use only greater than or less than. If again you have a range interval between some selections. So example here, items orders is 10 or fewer. You get discount of 0. If it's from 11 to 24, you get 10. If you order from 25 to 50, you get 15. 51 to or more, you get 20. So here we can write this as the following. If the orders is less than or equal to range 1, let's say range 1 will be the first range we have from 0 to or fewer. I mean, from 10 or fewer, 1. 11 to 24 will be 2, then 3, 4. So that's what we're doing here. And also we are writing it here. So we said that if the first condition is okay, we do the first discount. Second condition is true, we do second. Third condition true, we do third. Otherwise, we do the last one. So the same thing as writing here. If the items order is less than or equal to range 1, then we get the first discount. Else, if it's 2, we get second discount. Else, if 3, we get second. This is if you have a lot of conditions or different ranges. Now, they say we should always avoid a dead or unreachable path. This means I may have some conditions, actually nested conditions, but you may have some conditions that due the way you write it, you can never reach that condition to check. And we should always are trying to avoid it. Never ask a question if there's only one possible outcome. If I have only one answer, then there's no need to ask the question because the answer is only one. And also avoid testing the same range limit multiple times. I don't want to test the same interval more than once. Great. So this example of eliminating the dead path. The last option will never happen because here they say the items ordered is greater than range 3. But remember, we already have range 3 here. So we start from range 1. True, false is okay. We do something. If it's true, false, if it's okay, we do something. And we check range 3. Range 3 is true. If it's true, we do something. But if it's false, That's it. We don't have range 4. So why do you check for another range 3 if it's greater? It doesn't work because if the condition here it doesn't meet range 1, 2, and 3, then the last option will be so you don't need to have another condition. So that's why here they say don't do it. We don't reach this. The same concept here. Don't do the last. You have only 3 ranges, so you check up to 3. If the intervals is not among those 3 ranges, then the last one can be range 4, 110, and that's the last option. So that's no. Also, we should avoid testing the same range limit multiple times. So here you can see that we are testing the same thing down, yes, no, then yes, no again. And we should avoid that. We can combine multiple and or operators in an expression, and that's okay. Example given here, if a score 1 is greater than or equal to minimum score, and score 2 is greater than or equal to minimum score, and score 3 is greater than or equal, you can have as many combinations you want. So all these conditions have to be true. Then we say we pass. Otherwise, we fail. So else section will be there when the condition is false. Also, we talk about understanding the precedence. So if I have n and or, always the n will execute first before or. Unless the n is in a parenthesis, always parenthesis execute first. Same as arithmetic precedency. We know if I have arithmetic operation, always parenthesis first, the exponent, multiplication, division, then addition, subtraction. Here also the same thing, the parenthesis first, then the not, then n, then all will last. So here, for example, they say if a score 1 greater than or equal to minimum score, or score 2 is greater than or equal to minimum score, or score 3 is greater than or equal to minimum score, then do something. Now, when we look, all the conditions are the logical operators, they are all or. And score 1, we have score 2, score 3. So this will work. If it's or, it means all these 3 conditions, only one have to be true in order to pass. If you don't meet any of these 3 scores, then you fail. And now, the condition here says we have age is less than 12 or age is greater than 65 and rating is G. Now we have to be careful. The previous example, we have 3 conditions, but they are all. So we just execute from left to right. But here, we are not going to execute all first. We are going to execute N first. And executing all first, you may get different answer from if you execute N first. But with the order of precedency, first we said that if age is greater than or equal to 65 and rating equal to G, these 2 conditions have to be true first. Then we compare with the AG also. Best way is what we have here. Now you see that if I do this, really doesn't make logically, it's not correct because first I have a condition saying that if the age is greater than or equal to 65 and rating is G, in order this to be true, the n to be true, that means I have to be 65 or more. And also my rating should be G. So why do I compare 65 or more with less than 12? I'm already 65, so there's no need for 12. Unless you want to have it in this form. We say the age is less than or equal to 12 or age is greater than or equal to 12. This is what we want. Because first we want to compare the age. If you are either a baby, you are 12 or less, or you are a senior citizen, 65 or more. One of these conditions have to be true. Then with the rating is G. Then we do something. But the first one, if I want to execute the age first, I have to put it in parentheses. If I don't put it in parentheses, the first one, the n will execute first before or. But actually, we want all to be executed first. We want to know your age limit first before we check for the rating. So here they're telling us missing and or operators make logic more complicated. But again, it's not really complicated. You just have to be careful with the order of precedency, which operator will execute first and which operator will execute last. So we can avoid missing and or decision by using the nested if statement. Also, we saw from the beginning of the example, if I have two conditions and I don't want to use the logical operators, then I'll use the nesting if statement. One first if statement, then the second inside the if statement again, instead of combine them. So that can be the solution also. So that's the example here. We have a condition. If it's true, we have another condition. If it's true, then do something here. If it's false, check another condition before you do something. But if the first condition is false, don't do anything at all. So this is the same as the previous example we have with the and or condition. Remember, the rating is by itself. First, we need to check the two ages. So that's what we have here. Check the two. So if we go back here, first we check the age, either you are less than or equal to 12 years, or you are greater than or equal to 65. The answer we get, then we check with N for rating. So that's what we are doing for the nested loop here. Rating is housed. So if rating is yes, now let's check the age. If you are less than or equal to 12, then we give you a discount. And the same thing, if you are greater than 65 or 65, we also give you discount because this is for all session. When you look, or age is less than 12 or age is greater than, so any of these have to be true to get a discount. But here this time we are not using the logical operators but nested if statement, and that's what is here. If G, then age. If less than or equal to 12, discount. Else if greater than or 65, discount also. This is nested if. One last section is understanding the case structure. In many programming, we have a case structure, we call it a switch statement in Java. And the example is that you may have a lot of conditions. For example, this is a very good one. These two are the same. Here we are using the if else concept to do it. But for example, here, let's say I have a year. We say that if you are in the first year, you pay 175. Second year, you pay 50. Third year, you pay 100. If you are not of 1, 2, 3, then default, you pay 60. So this is like if else. The same thing we say, if the year is 1, then your tuition is 175. 175. Else, if you're year 2, then your tuition is 150. Else, if you're year 3, then the tuition is 100. Else, your tuition is 60. If you don't meet any of the three conditions, then you pay 60. But we can also use the case structure or the switch statement. First, we have the case, the variable name is year. So 1 here means if the year is 1, this is what you get. 2, this is what you get, etc. We will talk about this when we implement it in Java using it's called the switch statement. So in summary, in these lectures, we want details about selection statement for almost any programming language. As we said, this is a generic course for any programming language structure or logical flow. So again, we cover decision statement, the one-way, two-way. We also talk about the nested if statement. We talk about the logical operators, which we said we normally use it to combine 2 or more conditions. Before writing conditions, we talk about the relational operators, which are used for the conditions, like it must score greater than 40. Greater is a relational operators. We also talk about the case. This is a very short example. We saw only one example. Hopefully next week, it's almost time now for class Hopefully next week we will get a textbook and solve some examples on chapter 4. Meanwhile, we have a homework assignment that is due next week, Monday, for Unit 4 also. So I'm going to wait for a few seconds, see if we have any question. Okay, then I wish everybody the best then. First of all, let's look at our classroom. Where do I go? Let's stop this. And then let's look for our assignment. So now we are Unit 4. So this is Unit 4. Unit 4, Assignment 3, which is Chapter 4 review. But before that, we are going to do the quiz. The quiz will be, so for having released it, actually what I'm going to do, I'm going to release the quiz. You can take the quiz as a take-home quiz. I think we have one student already taking it. You don't have to take it again if you have taken it. Then we have the assignment. So we have the module 4 assignment. Actually, I'm in the wrong unit. No, the right unit. Okay. So we have assignment. And again, do your best to do it. Then we shall go through all of them. So first also, again, I'm going to post this video in the classroom, but we have one video already that we did. So again, the discussion, if you have any question, again, you can post it there. Module 4, quiz 1, I will release it after we finish. Then you have assignment, module 4, assignment 2, and another one, module 4, assignment 3. Assignment 1 is the quiz 1. So you get the quiz 1, assignment 2, and 3. And I'm going to release all of them. Do your best to do it until to be due on Monday. Actually, I'll make it on Sunday, so Monday we can review it. So if no question, then again, I will see everybody on Monday. And I'm going to post this